Hello children. Yesterday you people learned that angle subtended by a circle, the angle subtended by an arc of the circle at its center here, at the center is twice that of the angle subtended by the same arc at the circumference. Now if I name it as A, B, C and this is O. Now this angle will be 2 times that of this. Okay, so angle AOB is equal to 2 times angle ACB. That is what we learned yesterday. Now this can also be like this. This is a circle. Okay, and this is the center of the circle. Now this is the arc PQ, if I name it PQ. Now this is subtending an angle here at the center, subtending an angle here at the center. Now this is the angle subtended at the circumference. Now if I name it R. Now same thing here, the same whatever you learned it here, the same concept holds good here also. This angle will be twice that of this. Okay, so angle POQ will be equal to 2 times angle PRQ. PRQ. Okay, see here it was straight, but here it is cross. Okay, so here this is the angle formed at the circumference. So this angle here at the center will be 2 times that of this angle formed at the circumference. And this is another circle here. Here this is the center of the circle. Now I name it O. Okay, now see here, this is the arc AB. Okay, now this forms an angle at the center. Now this is another angle formed on the circumference. See here, if I name it C. See, this is the angle formed at the circumference. Okay, and this is the angle formed at the center. Now this angle formed here, this angle formed here will be 2 times this. So always remember this. This angle formed here will be 2 times this. If I have to calculate this, then it has to form somewhere here or somewhere here. Okay, but for this angle, this reflex angle, we call this as a reflex angle. The reflex angle formed will be twice this angle formed at the circumference. Okay, I hope you would have understood. This is yesterday's thing. Remember, angle formed by an arc, which is subtended this at the center, is twice that of the angle formed at the circumference. This is the first statement that you should remember. Okay, now we are going to move to the next theorem, theorem number 6. Theorem number 6. What does the theorem 6 say? The angle that is formed in the same segment, both the angles are going to be equal. Now this is the center of the circle. Now this is the arc. Now this is the arc AB. Now this AB forms an angle at the circumference here. Okay, see here like this. This is one angle formed. Now I will name it as C. Okay, the same arc is subtending an angle like this at D. Okay, now these two angles here, we need to prove that these two angles in the same segment. See here, if I draw a line here, these two will come in the same segment. Now these two angles formed are equal. Okay, we need to prove that here. Okay, now for that what we will do is, first of all we should write down what is given. Okay, write down what is given. given O is a center of the circle. Center of the circle. Okay, and AB is a arc which has subtended arc subtend an angle at a point C and at a point D on the circumference. On the circumference. This is given. Now we need to prove. What we need to prove? We need to prove angle ACB is equal to angle ADB. This is what we need to prove. Okay. Okay. Now construction. What we are going to construct? We have to join AO and BO. Join AO, OA and OB. You know they are the radius of the circle and they are equal. Now, based on the first theorem, now this AOB is the angle subtended by the arc AB at the center. Here, AOB is the angle subtended by the arc AB at the center. Now, this will be how much? Which it will be equal to ACB, twice ACB. Now, this angle will be 2 times this. Okay. So, now we need to prove. I will write the proof here. Proof. Okay. Now, angle AOB is angle subtended by arc AB at the center. So, the angle AOB will be equal to angle 2 times angle ACB. Reason? Theorem 5. Theorem 5. The angle subtended at the center, you need to write down the angle subtended at the center is equal to twice the angle subtended at the circumference. So this is 1. Now second one, similarly, angle AOB is equal to angle AOB is equal to 2 times angle, see here, this angle AOB will be 2 times angle ADB. ADB. Same thing here, based on theorem 5. Theorem 5. Okay. So, here this angle will be 2 times this. And same thing here, this angle will be 2 times this. Okay. So, this is 2. From 1 and 2, what we come across, angle 2 times angle ACB is equal to 2 times angle ABD. If I cancel 2 and 2 this side, angle ACB is equal to angle ABD. So therefore, what we are trying to prove, that the angles formed in the same segment are equal. The angles formed in the same segment are equal. Hence proved. hence proved. Now, I'll just explain everything once again, the theorem. Now, we need to prove that the angles subtended in the same segments are equal. This is the statement that you should remember always. The angles subtended in the same segment are equal. Given O is the center of the circle, AB is the arc. Now this subtends an angle at the center and then angle at the circumference at C and D. Now we need to prove that ACB is equal to ADB. So that is what we are trying to prove. Now construction join OA and OB, which is the radius of the circle. Now, according to the theorem number 5, what we have learned, angle AOB is angle subtended by the arc at the center, which is equal to 2 times the angle subtended at the circumference. So, angle AOB is equal to 2 times angle ACB. Same way, when we come to the next angle, here angle AOB is equal to angle ADB. So, that is 1 and 2. When we try to equate it here, see AOB is equal to this and AOB is equal to this. We try to equate things on the right hand side. 2 angle ACB is equal to 2 times angle ABD. 2 gets cancelled. So angle ACB is equal to angle ABD. Hence proved.